Oh, what's going on, everybody? Got another video here for you. We've got a related rate problem. Here it says the altitude of a triangle is increasing at a rate of 2 centimeters per minute, while the area of the triangle is increasing at a rate of 3.5 square centimeters per minute. At what rate is the base of the triangle changing when the altitude is 8.5 centimeters and the area is 90 square centimeters? All right, so right here when you look at this problem, you can see exactly what we're looking for. At what rate is the base of the triangle changing? And that's what they're wanting to know. What rate is the base of the triangle changing? So let's draw a triangle here and let's label it. So we've got some triangle here, and we've got a height we'll call H, and we've got the base B. Okay. Now the information it gives us is based on area of a triangle. So we know the area of the triangle is half the base times the height. Now that's the formula we're going to use. We're going to find the derivative of that. Well, let's go ahead and write down all the things that they're giving us. It says the altitude is increasing at 2 centimeters per minute. So the altitude increasing, that's also the altitude, that's the height. So that's the change in the height. So that tells us that dH dt, the change in height, is 2 centimeters. It's increasing. While the area of the triangle is increasing at a rate of 3.5 square centimeters. So that tells us how the area is changing. So that's dA dt is equal to 3.5. And it says, at what rate is the base of the triangle changing? Okay, at what rate is the base of the triangle changing? So the base changes, that's dB dt. That's what we're looking for. When the altitude is 8.5 centimeters, so that's when the altitude is 8.5. These are the numbers we're going to have to plug into whatever we get after we finish finding the derivative. And the area is 90 square centimeters. The area is 90 square centimeters. All right, so that's all the information that they give us. So let's see what all we have here. Let's go ahead and find this derivative, and then we'll go from there. So we got dA dt, we're differentiating with respect to t. That's going to be 1/2 times, and that's going to be the derivative of this. That's product rule. So that's going to be, we'll do the first function times the derivative of the second, plus the second function times the derivative of the first. See, it's going to be the first function times the derivative of the second, plus the second times the derivative of the first. And we're looking for dB dt, so let's solve for that. So first thing I'm going to do is multiply both sides by 2. So that's going to cancel out the 2's there, and I'll be left with 2 dA dt is equal to B dH dt plus H dB dt. So I want to get the derivative of the base by itself, so I'm going to subtract that to both sides. Minus B dH dt is equal to H dB dt, and then we'll divide everything through by H. So that is going to give me dB dt is equal to 2 over h dA dt minus b over h dH dt. All right, so there we have it. So we've got to plug in all these numbers. So look at this. I've got dH dt. So I've got something to plug in for dH dt. I've got dA dt, which is this. I've got something to plug in there. I'm looking for dB dt. H is 8.5, so I've got something to plug in for H here and here. Now the only thing I don't have is, notice right here, I have nothing to plug in for B. So what do we do there? Well, we got to figure out what B is. Well, it tells us that it says at what rate is the base of the triangle changing when the altitude is 8.5 and the area is 90. So when H is 8.5, the area is 90, so what does B need to be? So I've got 90 is equal to 1/2 B times H. And so if I solve this, I'll multiply both sides by 2 over 8.5. So that's going to give me 180 over 8.5 is equal to B. All right, so now we have stuff to plug in for everything, don't we? So I've got dB dt is equal to 2 over H, all right? 2 over H times dA dt, which is 3.5, minus B, which is 180 over 8.5 over H, which is 8.5, times dH dt, so that's going to be times 2. All right, so basically we'll have to plug all this into our calculator, but let's go ahead and simplify it first. We've got 2 times 3.5, that's going to be 7 over 8.5 minus, now look at this. This is going to be 180 over 8.5 times 1 over 8.5 times 2. So that's 8.5 over 1. So this divided by this is this times the reciprocal. And so now I get dB dt is equal to 7 over 8.5 minus 360 over 8.5 squared. And when I plug that into my calculator, I'm going to get negative 4.1591695. And that, let me leave me a little more room right there. And that will be centimeters per minute. So the base is actually decreasing. All right. So I hope that video helped. Hope you enjoyed it. Check out other videos. Give me a like, share, subscribe, comment, and I'll see y'all in the next one. Later.